everybody and welcome. This is Rob Riker, your instructor and mentor. In this video, I have a surprise for you. We're going to be doing a video on VPNs with NAT with an implementation. So as we go through this video, we're going to be taking a look at some of the variations of VPNs with NAT. Meaning, if you have a situation where you have NAT enabled on a gateway, this being a router or a firewall to provide internet access, but your company grows a little bit and you end up adding a second location, and you want to be able to provide secure connectivity between those two locations, but you don't want to go out and get a separate internet circuit. Is there a way to do that? There certainly is, and in this video we're going to show you how to do it. We're going to first take a look at the VPN topology overview, meaning what are we going to be covering and what does the topology look like that we're going to be tackling. Then we'll take a look at router NAT overview and the configurations. So we'll take a couple of minutes just to break down what the process looks like. How does a router quickly process NAT? How do you implement it? We'll do the exact same thing with the ASA, because NAT can be a little confusing on the ASA if you've never dealt with it before. And then we'll take a look at the VPN aspect of things. We'll have to make sure that we understand how the ASA and how the router both will be able to implement NAT and VPNs at the same time. So we take a look at our topology here. So both the router and the firewall are providing internet access. So both providing it via NAT. So this is what the topology looks like. We have PC1 on the left there. We have server 1 on the right. And we have the router that's acting as the internet gateway for PC1. And we have the ASA acting as the internet gateway for server 1. So what's going to end up happening is the router and the firewall are both going to provide internet access to the PC and the server via the shared internet circuit sitting between them. Now what's going to end up happening is both the router and the firewall are going to provide site-to-site VPN access as well, because we have a requirement where PC1 on the left needs to access server 1 on the right. So what we're going to be doing is configuring a VPN between the router and the ASA. Yes, you can configure a router and an ASA to form a site-to-site IPsec VPN with each other. It is possible. So let's go ahead and take a look at the actual overview of the configuration and what that looks like. So R1 provides PC1 internet connectivity via NAT, so network address translation. So NAT translates the internal IP addresses to the public IP address. That's what NAT does. Now, what's going to end up happening is, in order for the internet gateway to provide internet and VPN services, the gateway must be able to differentiate between internet destinations and non-internet destinations like VPN destinations. So PC1 to server 1. And the way that we're going to do that is, in this case here, I wanted to make sure that you understood that PC1 is using router 1 for internet connectivity. That's going to be the NAT piece. Now, the same thing applies. So when we look at the router configuration for NAT, the configuration is pretty simple. So the first thing we have to do is create an access list, an extended access list specifically. You can use a standard ACL for NAT configuration. However, if you need to provide VPN communication, this being site-to-site VPN communication with either another router, another firewall, or whatever other remote endpoint you're going to be forming a VPN peering with, you need an extended ACL. The reason why you need an extended ACL is because this first line in the syntax is deny IP 172.16.100/24 to 10.1.1.0/24. That's telling the router, do not NAT if the source and destination match on this ACL, which means that the source is 172.16.100 something, and the destination is 10.1.1. something, which is going to be behind router 1 and behind ASA 1. Those are going to be the two subnets that we're going to be messing with, just to prove that we don't have to use like prefixes either. We don't have to use the 10 space everywhere. We can use whatever addressing scheme we want. Now, because it's a deny, it means it won't be NATable. If this is the transmission that you're sending, so from PC1 to server 1, it's going to match on this line, which means it will not be NATed. The next line below that is saying permit IP 172.16.100.0/24 to any destination. This will allow PC1 to be NATed to things like the internet and stuff like that. Now the next step in the process is we're going to go ahead and apply the NAT configuration to the interface. So we have to tell NAT which interfaces are which. In this case here, gig 0/0 will be the outside, gig 0/1 will be the inside. And then last but certainly not least, we need to go ahead and apply it globally. So we need to tell NAT, we're going to say for any internal resources that want to go outside, we're going to use the NAT ACL. In this case here, NAT, the extended ACL called NAT. We're going to call that ACL down here in this line, and we're going to say, you know what? We want you to go out gig 0/0, but we want you to use PAT, which means all the internal addressing is going to be NATed over to a single public IP address. Now, the same concept applies with ASAs. So, ASA 1 provides server 1 internet connectivity via NAT. The NAT translates the internal IP address to the public IP address. In order for the internet gateway to provide internet and VPN services, the gateway must be able to differentiate between internet destinations and VPN destinations. And so here we have another example where ASA 1 is providing server 1 internet access. Now, when we talk about ASA NAT, it's a little bit different. If you've never dealt with it, it can be a little tricky to play with. So, the first line, and one thing to call out here just briefly, is that the way that ASA NAT works is it's in 3 different sections. You have section 1, section 2, and section 3. Section 1 is processed first, section 2 is processed second, and section 3 is processed third. Now, I'm not going to dive into the differences and how they all work. That's a whole nother separate video. But I want you to know that the first line that I'm showing you here is considered to be section 1 NAT. This is what they refer to as twice NAT, meaning that we're going to go in here and say, okay, we're going to NAT from the inside to the outside, so from the server 1 side of the network to the outside. But we're going to say the source static, meaning it's going to be the addressing is never going to change, and it's always going to be an up-up connection. So the NAT entries will always be there. We're going to NAT server 1 to server 1. So you might be like, why would you NAT it to itself? The reason why you need to NAT it to itself is because you need to be able to match the crypto ACL that we're going to configure in the next slide. Because we need to be able to tell the ASA, if you see any traffic coming from server 1 that potentially is going to PC 1, you have to NAT it to itself. So NAT server 1 to server 1. So NAT 10.1.1.10 to 10.1.1.10. So you're not changing the source IP address. And the destination is also going to be static, saying the PC1 is going to get NATed over to PC1. Now, I do have a couple of objects that I've had to create here. So when we're configuring this, we actually have to call the object itself. So when we call the object is just going to be a construct, saying call this a host, call this subnet, call this something on the firewall. And what we're doing is we're saying, with the SRV1, we're saying anything 10.1.1.0. Anything in the 10.1.1.0 subnet, go ahead and translate that from 10.1.1.0 to 10.1.1.0. And for PC1, translate that from 172.16.100.0 to 172.16.100.0. So you're doing it, it's referred to as twice NAT because you're translating itself to itself. This is needed in order for the ability to send traffic over the VPN. If this line of syntax right here, this first bullet item was not here, if this wasn't here, then the NAT configuration, the VPN configuration would fail, and you would not be able to send the traffic over the VPN because it would try to get NATed. Now, I do have dynamic NAT or PAT also enabled underneath server 1. We're saying underneath the object network of SRV1 for server 1, we're saying anything in the subnet of 10.1.1.0, I want you to go ahead and allow that to be NATed whenever the endpoint wants to go out to the internet. But I want you to NAT it to dynamic interface, meaning any on-demand flows that are going out to the interface, I want you to NAT to the interface being outside, which is going to be the public IP address that's assigned to the gig 0/0 interface on the ASA. That's how that's going to work. Now, as we dive into it a little bit further, we have the objects that we've created. Now, the objects have to be created before the twice NAT is implemented. Now, one thing of note, we're going to take a look at this on the command line here in just a moment. When you configure this line right here, this NAT, parentheses, inside, comma, outside, parentheses, space, dynamic, space, interface, this is what's referred to as auto NAT or object NAT. which means it's in section 2, which is processed second. So this NAT option up here is processed first, which means the traffic is going between server 1 and PC 1. Go ahead and maintain the source and destination IP addresses. Do not NAT them to the outside interface. Then any other traffic, if server 1 wants to go out to the internet and its destination is not something inside of the PC1 subnet, 172.16.100.0, then go ahead and NAT to the outside interface. That's what that's saying. Now, as we continue on, we're going to dive into phase 1 of the VPN configuration. Now, I'm breaking this down per phase because the individual configuration steps are a little tricky to understand if you've never dealt with a VPN configuration before on a router or an ASA. So I have the full configuration here, and I'm going to pull up a couple of notepad docs here in just a moment before we copy and paste the config in. So the first step in the process is creating the phase 1 ISACAM policy. This is going to be the communication between the router and the ASA for the control plane. So router to ASA communication. This has nothing to do with PC1 to server 1 communication. This is just router to router or router to ASA communication. So this is going to be a secure channel that's set up between the devices, and they're going to be using the pre-shared key of Cisco. So that's the phase 1 configuration. The phase 2 configuration is a little bit more involved. So let's go take a look at that. So the first step in the process here is we have to create the transform set. The transform set is made up of ESPE AES, meaning we're going to be using the advanced encryption standard to encrypt the data traffic between PC1 and server 2, or I'm sorry, PC1 and server 1. And this ESP SHA HMAC is an integrity add-on that is done as traffic going between PC1 and server 1, as that communication is going back and forth. What's happening is there's actually a hashing that's done between when the traffic is being sent back and forth. And that hash has to match on both ends. This way here, the router and the ASA know nothing has happened in flight between ASA1 and R1 that could potentially corrupt any of the data. No one's messed with the data in flight. That's what this SHA HMAC is. And the mode is tunnel. So the next step we have to do is we have to create the access list that is going to allow us to match on encrypted traffic. So this is going to be our VPN traffic. So this is what they refer to as interesting traffic. So we create an access list called extended VPN, and we go ahead and we say, okay, any traffic coming from 172.16.100.0/24 going to 10.1.1.0/24, go ahead, that traffic is going to be allowed to be encrypted. We will later call that ACL. We call the ACL, and we call the transform set of TSET from the crypto map. Now, these are two constructs that have to be configured globally and then mapped underneath the crypto map. And then we also have to set the peer. In this case here, the peer will be ASA1's public IP address, which is going to be 100.64.100.10. Now, once we have that in play and we have all that configured, the next step in the process is applying the crypto map to the gig 0/0 interface. What this is going to do is crypto is the very last step in the process. So when we go through and send the traffic to the endpoint, what's going to end up happening is as the traffic goes out gig 0/0, the crypto map is going to say, okay, are you coming from 172.16.100.0? But the answer is yes. And the destination is 10.1.1.0. If both come up as yes, I am going to 10.1.1.0. In other words, I am coming from PC1 going to server 1. Then you're going to match on this extended ACL that's called from the crypto map, and that particular traffic will be encrypted between the router and the ASA. So that's basically how that process comes into play. Now, we have the next step, which is going to be the ASA phase 1 configuration. The ASA VPN config is just a slightly more involved, so let's go ahead and take a look at that real quick. So the first step we have is, instead of using ISACAM, we use IKE v1. And the authentication is pre-shared. All these attributes have to match between the router and the ASA. So that's why I always recommend whenever you're configuring a VPN between any two endpoints, whether it's a router and a firewall, two routers, two firewalls, that whatever you do for phase 1, as soon as you're done configuring it, you go ahead and apply it to the other end so that you have the exact syntax available to you. The next stage is the pre-shared key part. Now, ASAs do a little bit differently than a router will. They use what they call a tunnel group. And the tunnel group is going to be basically where the traffic is going to be terminating on. So that's the stanza that ASAs use. So we have to use the IP address of the remote end, meaning the public IP address of R1. Now, there are other methods you could use. We're not going to get into them at the moment. And we're going to use the type of IPsec L2L or LAN to LAN, which is going to be a site to site VPN. The next step is going to be the IPsec attributes. And we're keeping this, like I've mentioned before, very vanilla, very, very basic. And all we have to do is say IKE v1 pre-shared key Cisco. The pre-shared keys between the router and the ASA need to be 100% exact the same, so that they can authenticate each other and they can decrypt everything that's going on. Now, the next thing that's happening is the phase 2 configuration. So the first step we have is the transform set. I kind of put a little bit of spacing here to make it easier for you guys to read. We have the transform set. We're still calling ESP AES, so we want to use both ends have to match. And we're going to use a SHA hashing variable to make sure that the data that's encrypted between the endpoints didn't get messed with in flight. Then we have the crypto map configuration. Very similar to what you saw on the router, except for we don't go underneath the 3 separate lines. And we say the entry number, and then we set the peer, and then we apply the transform set. The VPN configuration is just the opposite of what we did on the router. So instead of being 172.16.100.0, it's 10.1.1.0/24 to 172.16.100.0/24. Then we enable the crypto map on the outside interface. Then once we do that, then we have to enable IKE v1 on the interface. So we have to make sure that IKE v1 has been enabled on the interface for the outside configuration. And then we're good. So, guess what we get to go do now, guys? We actually get to go implement all of this stuff. So let me go ahead and pull up Super Putty, because I have Super Putty ready and rocking, ready to go. So let me go ahead and get this ready to go. So let's go ahead and swing this over. So what we have on the left and we have the right, we have PC1 talking to server 1. So let me go ahead and undebug all real quick, because I was doing some testing on the back end before I did this. So this won't work 100%. So in the interest of time, because we're sitting in right about the almost 20-minute mark, so the next couple of minutes we'll be done with this. So this is the router config. So what we would do is, and I have this in the order in which you would apply it. So you have the extended ACL that denies traffic going between the server. Let me go ahead and get myself out of the way here. Between the PC1 and the server from being NATed, traffic going from PC1 to the internet will be allowed. We have the NAT statements, the crypto map. So all the syntax right here. If at any point in time you wanted to have the configuration available to you, you can pause the video and I will actually go ahead and get myself out of the way one more time, and you guys can go ahead and copy this config down and all that good stuff. So I'm just going to go ahead and copy it, go to router 1, go to global config. Now I'm going to go ahead and paste this in place, and there we go. So now I'm going to jump out of global config, and so we should be good to go there. And then I'll do the same thing for ASA1. Go over on ASA1. Let me go ahead and come down here. We go grab the config for it and drag it over. So again, it's a lot of config, and we have the VPN configuration is good to go. So we're going to go ahead and copy all that, and we're going to go to global config and copy and paste it in. So there we go. So we're good to go. So any outputs that you see, this is actually a working configuration. So let me actually go ahead and post that back up real quick just for a second for you guys in case you missed it. So this is the ASA config. It's a little bit more involved and stuff like that. Let me go ahead and do a show run access list real quick just for a moment. And so this is the syntax you would use. Access list extended, or VPN extended permit 10.1.1.0/24 to 172.16.100.0/24. That's the VPN configuration. So now that we have that going on, and if we do a show crypto ISA SA, we actually have an active VPN up and running. So let me go ahead and pull up PC1 real quick. PC1 is right here. So we're going to go ahead and pull up PC1. I'm going to drag him over. And I'm going to, on PC1, I'm going to go here. I'm going to grab the command prompt. And I'm going to type in ping 10.1.1.10. Can I ping? I 100% can ping across the VPN. Now, what I really want to know is if I was to go and connect on Internet Explorer, let me also make sure that I can ping the internet. So ping google.com. This is a 100% legitimate internet connection. There's nothing simulated here. This is real internet. So what I'm going to go do now is I want to go ahead and open up the web browser. And we're going to go ahead and stop the connection there. I'm going to go ahead and inside of here, I'm going to type in 10.1.1.10 and hit the enter key. And so just in a moment, we should have the web browser of server 1 pull up, which we do. And if we go back to here and we do a show crypto IPsec SA and hit the enter key, we're going to see traffic is going back and forth. Now there's a lot of output here, so I want to negate some of it. I'm going to type in pipe include PKTS. That's going to show me just the packets going back and forth. So if I go back to this guy and I hit the up arrow and I hit the enter key a few times, well, actually no, I want to do the other connection. I want to ping 10.1.1.10. Now you see that we send 4 more packets. So if we come down here, we should see incrementing 4 more packets have been sent across the wire. On the ASA, we want to do the exact same thing. We're going to do a show crypto ASA SA. We have an active VPN connection to router 1. If we do a show crypto IPsec SA and hit the enter key, we have the exact same setup. If we come up here and do a pipe include PKTS, we get the same output. So, ladies and gentlemen, we have successfully configured a site-to-site VPN with NAT. And let me go on to server 1 real quick just to prove that server 1 actually has communication with the outside world. Go ahead and bring that over just ever so quickly. And so I'm going to go ahead and on here, I'm going to go ahead and ping google.com. And momentarily that should go through. Oh, you know what? I do not have ICMP being inspected. So let me go ahead and fix that real quick. Do show run policy map. That's an easy fix. So I'm just going to go over here to the global policy. Actually, let me scoot this over just a little bit so you can see it. I'll go up here. I'll go to this inspection. I'll go to global config. Right click and paste that in. I'll say inspect ICMP, which is not done by default. So what I'm going to go ahead and do now is go back here, hit the up arrow, and now we get replies. So that was a oversight on my part. I apologize about that. But now we're done. We have full internet connectivity. If I wanted to pull up the internet and go surf, I could. And I'd still be able to communicate with PC1 if I wanted to do so. If I wanted to ping 172.16.100.10. I believe that is the IP address of PC1. If not, I can double check that real quick. IP config 11. Sorry, I apologize. So let's go ahead and Control C that, hit the up arrow, and do a .11. And so I can ping across the wire. So both server 1 and PC1 can both ping each other, and that's the whole point here. So we have internet connectivity. Everything looks pretty good. I want to go ahead and wrap up the video real quick. So we have the implementation in place. So the next thing we're going to do is recap. So in this video, we went ahead and we took a look at configuring a VPN. So we took a look at the overview of what the topology looked like. And then we went through and discussed the difference between ASA and router NAT and how it's used in order to allow the communication that we need. We took a look at router and VPN configuration. I'd like to thank you guys for hanging out with me for the last little bit. I wanted to have a little bit more sustenance to the video and actual implementation. We will add the configuration to the description, so you can go ahead and open up the description. That information will be there. Everything will be available to you. And until next time, guys, thanks so much for stopping by. And until next time, guys, take it easy.
Jacob Hess here. Thank you guys for viewing the video. I hope you really enjoyed it. And I'd also like to remind you that if you're truly serious about your career in information technology, be sure to check out our Career Blueprint and Engineer Training Program at www.zerotoengineer.com.